NASA just announced something that almost never happens in the history of large space missions: a telescope that is ahead of schedule, under budget, and now targeting a launch date months earlier than anyone expected. The countdown to September has officially begun. On April 21st, 2026, 3 days ago, NASA Administrator Jared Isaacman walked into the largest clean room at the agency's Goddard Space Flight Center in Greenbelt, Maryland. Behind him stood the completed Nancy Grace Roman Space Telescope, fully assembled. More than 42 feet tall and 14 feet wide, gleaming under the clean room lights after years of engineering, testing, and refinement. At a news conference that the astronomy community had been waiting for, Isaacman made the announcement official. NASA is now targeting early September 2026 as the launch date for the Roman Space Telescope, months ahead of the agency's committed deadline of no later than May 2027. What would take Hubble 2,000 years to process, he told the room, Roman can do in a year. The telescope will ship to Kennedy Space Center in June, complete its final launch preparations at a facility being upgraded specifically for its arrival, and lift off on a SpaceX Falcon Heavy rocket from Launch Complex 39A, the same historic pad that launched the Apollo missions and the Space Shuttle. The new era of astronomy has a launch date, September 2026. The significance of this announcement cannot be separated from the context of what has been happening in NASA's science program. The same week Isaacman announced Roman's accelerated launch, NASA submitted its fiscal year 2027 budget proposal to Congress, a proposal that calls for cutting the agency's science funding by 47% from 2026 levels, canceling more than 50 science missions currently in development or extended operations, and eliminating approximately a dozen astrophysics missions, including the Chandra X-ray Observatory and several contributions to international science partnerships. The contrast is jarring. On one side of the ledger, the most powerful wide-field space telescope ever built is finishing testing ahead of schedule and shipping to the launch pad. On the other side, the budget framework surrounding it is proposing the deepest cuts to NASA's science portfolio in the agency's history. Isaacman addressed this tension directly at the news conference, stating that Roman is not the last flagship mission for NASA, and that he expects flagship-class missions to continue despite the constrained budget environment. Whether Congress agrees is a question that will be answered over the coming months. But for right now, Roman is flying, and that matters enormously for the future of astronomy. Before the telescope can reach its launch pad, it must first complete the final steps of its journey from Goddard. Jackie Townsend, Roman's deputy project manager, confirmed at the April 21st event that the observatory had just completed its comprehensive performance test, the full systems checkout conducted after environmental testing, and that everything went exceptionally well. The remaining tasks before shipment are few and specific. The team still needs to verify the deployment sequence for the telescope's antennas, testing the process by which the antennas unfold in the configuration they will use in space. Engineers also need to complete minor repairs on a small number of solar panels. These are not significant engineering challenges. They are close-out tasks on a machine that has already passed every major test it has been given. By mid-June, the telescope will be packed into its shipping container and transported south from Maryland to Florida. The journey itself requires extraordinary care. The container is temperature-controlled, vibration-monitored, and escorted at every stage to ensure that a machine worth $4.3 billion in decades of scientific development arrives at its destination in exactly the condition it left. The facility waiting for Roman at Kennedy Space Center has been specifically upgraded to receive it. NASA's Payload Hazardous Servicing Facility, known as the PHSF, is a 40-year-old building that began operations in 1986 during the Space Shuttle program. It is a dedicated dual-use complex combining a clean room environment with hazardous materials handling capability, designed for the final stages of spacecraft processing before launch. The PHSF has an impressive history. It supported Hubble Space Telescope payload processing for multiple servicing missions. It processed the Mars 2020 Perseverance rover before its launch. It handled NASA's Europa Clipper spacecraft for its journey to Jupiter's moon Europa, and now it is being prepared for Rome. The facility has undergone a series of targeted upgrades specifically for Roman's arrival. New air showers, systems that blast high-velocity HEPA-filtered air over personnel before they enter the clean room, have been installed to prevent contamination. The HVAC system has been upgraded with new chiller coils to ensure the airlock and clean room remain at precisely controlled temperature and humidity, with backup. Systems available if the primary system fails. The compressed air system has been updated with a new pressure tank, air dryer, and regulator panel to supply clean, reliable compressed air for moving hardware across the facility floor. An Operation one NASA engineer described as being like an air hockey table, but on a much larger scale. Massive volumes of filtered air circulate continuously through the facility to prevent even microscopic outside contaminants from reaching the telescope's optics and instruments. At the PHSF, Roman will go through its final series of inspections and checkouts. Engineers will verify that the telescope survived the shipping journey from Goddard without any changes to its alignment, calibration, or structural integrity. They will perform a final systems review of all instruments and subsystems. Then comes one of the most critical and delicate steps in any space mission: fueling. The telescope will be loaded with the hydrazine propellant it will use in space to make precise orbital adjustments, maintain its pointing accuracy, and execute the maneuvers needed to insert it into its final operating position 1 million miles from Earth. Hydrazine is a highly toxic and reactive compound, which is why the hazardous materials handling capability of the PHSF is specifically designed for this phase. The facility manager, Scott Boehmer, described the responsibility plainly. His team's job is to ensure the highest practical probability of launch success for these incredibly sophisticated and delicate spacecraft. They are, he said, the common thread, combining the capabilities of commercial rockets with NASA's scientific spacecraft, and they bring experience from processing everything from space telescopes to Mars rovers to deep space probes within the same building. Once fueling and final closeouts are complete at the PHSF, Roman will be transported to Launch Complex 39A and encapsulated inside the Falcon Heavy fairing, the protective nose cone that shields the telescope during the violent first minutes of flight through Earth's atmosphere. The SpaceX Falcon Heavy is one of the most powerful operational rockets currently flying, with a lift capacity to low Earth orbit of approximately 63 metric tons. For Roman, the Falcon Heavy will not be delivering the telescope to low Earth orbit. It will be sending it on a trajectory toward the Sun-Earth L2 Lagrange point, a gravitationally stable location approximately 1 million miles from Earth, in the direction directly away from the Sun. L2 is where the James Webb Space Telescope currently operates, and it is where Roman will join it. The journey from launch to final operational orbit takes several weeks, during which Roman's systems will be powered on, its instruments will be activated and calibrated, and its deployable structures, solar arrays, radiators, and antenna systems, will be unfurled and tested. If everything proceeds according to plan, Roman will begin its science operations approximately 6 months after launch, in the first months of 2027. The launch contract between NASA and SpaceX for the Falcon Heavy was signed in 2022, specifying a launch cost of approximately $255 million and a rocket readiness deadline of October 2026. Roman's early September target date keeps NASA comfortably within that contractual framework. The launch will take place from Launch Complex 39A, a pad with a lineage that runs from the Saturn V that sent Apollo 11 to the Moon through the Space Shuttle program and now into the commercial launch era. This is not a coincidence. NASA specifically chose LC-39A because of its heritage, its operational reliability, and the tight integration between the Kennedy Space Center infrastructure and SpaceX's Falcon Heavy processing facilities at that pad. Understanding why Roman reaching Kennedy in June and launching in September is such a remarkable milestone requires knowing the history of how this telescope came to exist, and how many times it almost did not. The mission that became Roman was first, recommended in 2010 by the United States National Research Council's Decadal Survey, the astronomy community's formal ranking of the highest priority science missions for the coming decade. It was ranked as the single top priority for astrophysics in the 2010s. It was formally approved for development in February 2016. And then, over the following years, it faced 3 consecutive budget proposals under the first Trump administration that called for its cancellation. 3 years in a row, the White House proposed eliminating it. 3 years in a row, Congress refused. Lawmakers on both sides of the aisle protected Roman because the astronomy community made clear, repeatedly and loudly, that this telescope represented the most important wide-field survey capability in NASA's planned science portfolio. The mission survived, development continued, and in November 2025, construction was officially completed on time. The telescope that was proposed for cancellation 3 times is now sitting in a clean room at Goddard, fully assembled, waiting to be shipped to the launch pad. The scientific promise, waiting on the other side of this launch, is staggering. Roman's 300-megapixel wide-field instrument will survey the sky with the same sharpness as Hubble, but across a field of view 100 times larger, and up to 200 times larger than the James Webb Space Telescope's imaging cameras. In its 5-year primary mission, the telescope is projected to gather 20,000 terabytes of data, catalog over 100,000 distant worlds beyond our solar system, image hundreds of millions of stars, and capture over 1 billion galaxies. It will map the distribution of dark matter across cosmic time using gravitational lensing measurements of extraordinary precision. It will track the expansion history of the universe through surveys of hundreds of thousands of Type Ia supernovae and billions of galaxies, directly attacking the mystery of dark energy. the unknown force making up 68% of the universe that is causing the cosmic expansion to accelerate. And through its Coronagraph instrument, it will attempt the first direct imaging of giant planets orbiting other stars, blocking the blinding light of those stars to reveal the faint reflected light of worlds circling them, a technology step that leads eventually toward the direct imaging of Earth-like planets. There is one more dimension to the September launch timeline that deserves attention, and it is the context it creates for the broader state of NASA's program right now. Roman's launch will come just 5 months after the Artemis II mission, the first crewed lunar flyby in over 50 years, which flew in early April 2026 and returned its 4-person crew safely to Earth after a 9-day journey around the moon. NASA is now simultaneously preparing for Artemis III, with Crawler Transporter 2 already moving hardware and rocket assembly for the next lunar mission beginning this month. And in September, while Artemis III preparations are advancing at the Vehicle Assembly Building, Roman will leave Launch Complex 39A and begin its journey to 1 million miles away. 2 programs, 2 completely different frontiers, both advanced at the same time, from the same launch site in the same year. For an agency facing the most severe proposed budget cuts in its history, the operational momentum of this moment is striking. The question of whether that momentum can be sustained through what comes next, the congressional budget battles, the mission cancellations being proposed, the long road to Artemis III, and eventually Mars, is the defining question for American space science in the coming decade. The teams at Kennedy who will process Roman between June and September are not new to this kind of work. The PHSF has supported some of the most consequential spacecraft launches in NASA history. Hubble itself was processed in this facility. The technicians and engineers who will receive Roman, inspect it, fuel it, and certify it for flight carry institutional knowledge that spans 4 decades of launching the most sophisticated science instruments humanity has ever built. Scott Boehmer, the facility manager, noted that his team is a common thread running across generations of NASA missions, connecting the eras of the space shuttle to the eras of commercial rockets and next-generation observatories. Roman will be in careful hands from the moment it arrives in Florida to the moment the Falcon Heavy's engines ignite. And if everything proceeds as currently planned, sometime in early September 2026, the skies above Florida's Space Coast will light up as the Falcon Heavy's 27 Merlin engines ignite, simultaneously lifting $4.3 billion worth of precision optics, mirrors, and instruments off the ground and sending them toward a destination 1 million miles away. The countdown to September has begun, and the universe, as we currently understand it, is about to change. NASA Administrator Isaac Mann used a phrase at the April 24th news conference that captures what Roman represents at this specific moment in the agency's history. He called it a true success story of what we can achieve when public investment, institutional expertise, and private enterprise come together to take on near impossible missions that change the world. In an era when NASA's science budget is under its most severe pressure in decades, when mission cancellations are being proposed on a scale the agency has not faced before, and when the geopolitical competition to lead humanity's exploration of space is more intense than at any point since the original space race, Roman stands as evidence that transformational science is still being built, still being launched, and still arriving ahead of schedule. The telescope is 42 feet tall. It weighs approximately 4,200 pounds. It cost $4.3 billion and took more than a decade to move from concept to completed hardware. It ships to Kennedy Space Center in June. It launches in September. And when it opens its eye on the universe from 1 million miles away from Earth, the atlas of the cosmos is going to be rewritten,